Hello everyone. In this video we're going to be solving an interesting quartic equation. We have x to the fourth minus 16x squared plus 40x equals 25, and we're going to be looking for x values. We're going to find all the solutions. I'm also going to show you a graph that verifies our findings. And I'll be presenting two methods. Let's start with the first method. Now this is first of all a reduced quartic, meaning that we don't have a term with x cubed. So if you're solving a quartic equation with the quartic formula, you want to get rid of x cubed, and then you want to write this. There's a couple different ways to go about it, but you're going to end up getting a cubic equation in one of the methods, and then that cubic equation can be solved by reducing the power to a second power. You should be familiar with the cubic formula by now because we've done quite a few problems. Hopefully you looked at those equations or problems on the channel. If you didn't, please check it out. Anyway, so this is a special type of quartic. I'll tell you why in a little bit. But before we get to that, the specialty, let's go ahead and solve it with the first method, which is going to depend on factoring a polynomial. You could use the quartic formula. It's going to be a little painful. If you know of an easy way to do it, please let me know. Anyways, so here's what I'm going to do. I'm going to write this equation, having taken advantage of the fact that we don't have the cubic. I'm going to write it as a product of two quadratics, one of which is x squared plus ax plus 5, and the second x squared minus ax minus 5. Let me explain my reasoning here. First of all, I assume that negative 25 can be factored into 5 and negative 5, which may not be true, by the way, because it could also be 25 and negative 1 or negative 25 and 1. So there's other options if the coefficients are all integers, of course. We're looking for easy way out. And the second assumption that I made, or why I wrote it this way, is I put plus ax and minus x. You know what? X cubed term is going to disappear that way, because when you multiply these and these, they're going to cancel out. That's why I wrote the coefficient of x that way. And this actually always works if you don't have x cubed. That's why not having x cubed is a good thing. Make sense? So let's go ahead and do the following. We're going to distribute here. Take care of all the coefficients. If something is going to cancel out, obviously you don't have to worry about x cubed because we know it's going to cancel out. And how do I know that? X cubed only comes from a product of x and x squared. That's the only way to get it from here. So here's what's going to happen. We're going to distribute to keep a long story short. This is going to give you x to the fourth minus a squared x squared minus 10ax minus 25. And then that should equal our equation x to the fourth minus 16x squared plus 40x minus 25. And actually we have a pretty good match, don't you think? If you look at it very carefully, you're going to notice that the coefficient of x squared is negative 16, so negative a squared should be negative 16. And the coefficient of x is negative 10a, negative 10a should equal 40. Which means what? Negative a squared equals negative 16 means a squared equals 16, and that means a equals 4 or a equals negative 4. Don't get me wrong. If they give you the square root of 16 in the real world, then it's 4, because we always take the positive square root. But if you're dealing with complex roots, then there are two complex roots, 4 and negative 4. That's where it comes from. But in the real world, when we say, okay, find the number whose square equals 16, then there are two real numbers. Make sense? So those are two different things. And if you take the square root of both sides, you'll end up with an absolute value which takes care of the plus minus signs. Okay, so now the second piece of information that I get from here is negative 10a is equal to 40, which means a is equal to negative 4. So these two have to be satisfied at the same time. So we have an and, which means a equals 4 is impossible. We have to go with a equals negative 4. And guess what? That gives us our polynomial in the factored form. So we're done, pretty much, right? Okay, it wasn't too bad. So we can go ahead, since a is negative 4, we can write our equation as x squared minus 4x plus 5, and x squared plus 4x minus 5, right? Okay, so the signs differ like that. So we're going to be careful here. because A couldn't be 4, you might be thinking, hey, it's symmetrical. Well, the choice of A, the way I wrote the A is because I chose A to be in the polynomial whose constant is 5, by that sentence. That's why it's like this. But if you do the other way around, they're going to switch. Anyways, so we got a simple equation, 2 quadratics, set them equal to 0 and solve it. X squared minus 4x plus 5 equals 0 gives you x equals 2 plus I and x equals 2 minus I. Easy, right? Piece of cake. And the other equation, x squared plus 4x minus 5 equals 0, is also a special quadratic, because remember what I told you about guessing some of the roots, especially with the rational root theorem, or you can do log division or whatever, checking the sum of coefficients. And in this case, 1 plus 4 minus 5 is equal to 0, which means x equals 1 is a solution. And the other solution, you can use Vieta's formulas. The product is -5, or whatever you use. Either the quadratic formula is fine, and you get -5. So we got 4 solutions. It's a quartic. 2 of them are real, 2 of them are not real, but we found all the solutions. Can a quartic have more than 4 solutions? Not a polynomial one. Okay? Makes sense? So let's go ahead and take a look at the second. Did I do the first? Yeah, okay. Anyways, I get confused. I think I got the first method first. Now this is the second method. So the second method obviously depends on a trick, because this is a special type of equation, right? I told you at the beginning, remember? This was the original problem, and we'll also show you a graph at the end. Now let's put everything on the same side to complete the quartic, and now we have a complete quartic. And guess what? This expression can be written as follows. And then you might be questioning why. Of course, you should always question these things. Scientific method, right? Okay, great. So I wrote it that way because this is a perfect square. And guess what? That is perfect, isn't it? So now, not only that's a perfect square, but we have actually double perfect. We have a difference of 2 squares, which is awesome. So here's what we have. X squared minus 4x minus 5, check it out, squared equals 0. And yay, this is easy to solve. You can either go with difference of 2 squares, or if you like this better, you can do that too. Let's go ahead and do it. A squared equals b squared implies a is b, or a is negative b. So from here we get the following. X squared equals 4x minus 5, or x squared is the opposite of 4x minus 5, because if you square opposites, you get the same thing. So now we get x squared minus 4x plus 5 equals 0, which gives us 2 plus minus I. And this equation gives us x squared plus 4x minus 5 equals 0. Remember the sum of the coefficients, x equals 1 and x equals -5. So that also gives you us the same 4 solutions. Of course, it should be that way. So let's go ahead and take a look at the graph, and we'll finish up. So the graph also verifies that there are 2 real solutions, -5 and 1. The others are complex, non-real, and you only see part of the graph because it kind of curves nicely, but that's the x-axis, in case you didn't know. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed this. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.